Hi, today we're talking about CCM 6, finding the greatest common factor. A factor is when two or more numbers are multiplied. Each of those numbers are called a factor of the product. So, for example, if I multiplied 6 times 5, I would get 30. So 6 and 5 are factors of 30. The greatest common factor, otherwise known as GCF, is the greatest factor that two or more numbers have in common. Some strategies we're going to be using today are using prime factorization, a Venn diagram, and a ladder. So prime factorization, if I was asked to find the GCF of 12 and 18, I would make a factor tree. So to get 12, I would multiply 3 times 4. And then to get 4, I would multiply 2 times 2. All of these remaining numbers down here are prime numbers. That's why it's called prime factorization. It's to get the prime factors of the number 12. Then I would do the same thing for the number 18. 2 times 9 is 18. 2 is prime, 9 is not. So I need to continue breaking that number down. 3 times 3 equals 9. And the number 3 is prime, so I'm done. So what I went and did is I circled the numbers they have in common. So they have a 3 in common, and I wrote it down. And they have a 2 in common, and I wrote it down. Those are the factors they have in common. Now I just have to multiply those together to get a product, and that product is my GCF. In this case, it's 6. So let's do one together. I've got 30 and 75. Well, I know that 3 times 10 is 30, and then 2 times 5 is 10. So all of my numbers down here are prime numbers, so I'm good here. Then I've got the number 75. I know that 3 times 25 is 75, and 5 times 5 is 25. So I've got my prime factorization of the number 75 here. And then I just go through and find what they have in common. They have a 3 in common, and they have a 5 in common. I write them down. 3 times 5 is 15. So the GCF of 30 and 75 is 15. Another method is called the Venn diagram. It's the same example we just did, but visually it's a little different. So here's a Venn diagram. You might remember this from language arts, but over here I've got my number 30. And I just found the prime factorization of it. 2 times 3 times 5 is 30. And I've got the number 75. Again, 3 times 5 times 5 is 75. I'm going to put these numbers in the Venn diagram. And the outer space here is where I put the numbers that they do not have in common. And on the inside where the circles overlap is where I put the numbers that they do have in common. So 30 just has the number 2, but it shares a 3 and a 5 with the number 75. And then so I already took care of the 3 and the 5 for the 75, but the 5 this other 5 is not a common factor with the number 30. Only one of the 5s worked. So for the GCF, I just take what they had in common, greatest common factor. In this case, I have 3 and 5. 3 times 5 is 15. So the GCF is the product of the common prime numbers. So in a Venn diagram, you can see visually what they have in common. The last method we're doing is using a ladder. The ladder method is actually my favorite method, and a little slogan that you can remember for the ladder method is GCF, just the left. So let me walk you through the ladder method. The ladder method is sort of like upside down division. I've got my two numbers, 15 and 45. I'm supposed to find the GCF of those. So I'm going to divide out from it a number that I know that they have in common. So I drew a upside down division bar, also known as one of my ladders, and I'm going to divide out of these two numbers a 3. So 15 divided by 3 is 5. 45 divided by 3 is 15. I can divide out a 5 from both of those numbers. As a result, I would get a 1 and a 3. I cannot really take out anything other than 1 from these two numbers, so I'm done with my dividing. And the GCF is just the left, just the numbers on the left side. I multiply those numbers together and I get 15. That's my GCF. So let's try this one together. I've got 56 and 40. Well, they're both even, so I know 2 goes into both numbers. 2 goes into 56 28 times. I had to do that one on the side of my paper, so don't think I'm a super genius, really. I had to do this one beforehand, which you will have to too when you get to the other problems on the next board. 2 goes into 40 20 times. They're both even again. 2 can go into 28 14 times. 2 can go into 20 10 times. I've got another set of even numbers, so 2 can go into 14 7 times. 2 goes into 10 5 times. There's nothing else I can fit into 7 and 5, so I'm done. I can divide 1 into them, but that's not really going to help me finding the GCF. Remember, the GCF is just the left, so multiply 2 times 2 times 2, and I get 8. That's my GCF for this problem. Alright, what I want you to do is I want you to find the GCF of these 3 problems using any method that you saw today and any method that you've been using in class. Why don't you pause the video here, try these problems on your paper, then when you're ready, push play, and the answers will be revealed. 18, 32, 9, 10, 16. So that's it to GCF. Okay, so for 18 and 32, the only number that could go into that they had in common, the only factor they had in common was 2. 21 and 84. I know that 3 can go into both of these numbers. The reason I know that is because if I add the digits, 2 plus 1 is 3, and 3 is divisible by 3. Then if I add 8 and 4, 8 plus 4 is 12, and 12 is also divisible by 3. So these two numbers are both divisible by 3. 3 goes into 21 7 times. 3 goes into 84 28 times. Again, had to do that one on paper before I put it up here. Then I've got 7 and 28. I know that 7 goes into both of these numbers. And I'm all done here pulling out my factors. If I multiply 3 times 7, I get 21, and that's my GCF. And now I've got a set of 3 numbers. You can treat this the same way you treat 2 numbers. So I'm going to pull out a number I know that they have in common. These numbers are all even, so I'm going to pull out a 2. 2 goes into 4 twice. 2 goes into 20 10 times. 2 goes into 28 14 times. I've got even numbers again, so I can pull out another 2. 2 goes into 2 once, 10 5 times, 14 7 times. And remember, GCF is just the left if you're using the ladder method, so 2 times 2 is 4. That's my GCF of these 3 numbers. So you just solved a whole bunch of GCF problems. Great job.